Hey folks, Crazy Marty here. Gonna talk to you folks about electricity and what it takes to do shore power, the plugs that they like to use on different cables, and also if you have an inverter or you're planning on doing an inverter, just what it takes to make 120 volts out of 12 volts DC and the amount of amperage that's drawn on just basic things like shop vac, let's say. We'll use a shop vac. Anyways, we're gonna go into that stuff right now and I'll show you guys what's up. So here we are into electrical. Now this is what they call a twist lock plug. This is, you'll find this as a standard on a lot of your horse trailers. So what we have is let me get stuff down here. So we have three prongs and a ground, all right? This is the ground, this is the hot leg, this is the hot leg, and this is the neutral. So neutral and ground are basically the same thing. This is 120 volts, and this one's 120 volts. And if you measure between this pin and that pin and this pin and that pin, you're gonna get 120 volts. But if you measure between this pin and this pin, you'll get 240 volts. Or if you measure between the ground and the ground, you get nothing because it's basically bonded together. At some point in the system, it should be. Or between the ground and this pin or this pin, you're going to get 120 volts. This is a 50 amp plug. This is what it looks like on the other end. So this would be the other end of your horse trailer, and here's the this is what they call a dog bone. So this does 30 amps to 50 amps. Now these are a little bit different the way they're wired in compared to this. This is very simple. You have a ground, you have a neutral, and you have your two hot legs. These are both 120 volts each when measured with your voltmeter between this leg and this leg, or this leg and this leg. So you have L1, L2, neutral, and ground. Doors closing. Kind of lost my train of thought there with the door closing on me. Okay, so that's your basic setup on this plug here. This goes into your house or whatever at the trailer park or whatever you're going to be at. So like I said, this is a ground, or this is a neutral, and this is a ground. Basically these are the same to a degree. They're tied together somewhere. This one goes to earth, this one goes up to the pole, which is tied to the earth and everything else. So this is the hot leg and this is the hot leg. These are the ones you got to be careful of, because when you check your voltage with your voltmeter across these two pins here, you put your voltmeter one leg on here and the other test lead on there, you're going to get 240 volts. But if you go from here to here or from here to here, you get 120 volts. Or if you go from here to here and here to here, you get 120 volts. But when you cross the two there with your test meter, you're going to get 240. That works the same way with this thing here. This thing plugs in. Okay, so now we're going from 50 amps of power service. This is a 50 amp power service cord, and it is, what size is this thing? Mighty cord, blah blah blah, RV, where are the numbers? This is a 3 by 13 millimeter, so it should be like a number 10. This is like a number, this is basically a 410 is what it is. So there's 4 wires in here and a 10 gauge. So what we're doing now, by putting a dog bone on, we're going to go from 50 amp service to 30 amp service. The dog bone, stay open, door. It's pissing me off. I command thee to stay. Okay, so now we have our dog bone. This is a 50 amp service and this is a 30 amp service. This is completely different than this. So you have to understand that the way this stuff is set up is completely different wired internally. So here we have our 120 volt leg, our 120 volt leg, our neutral leg, and our ground. Okay? And if you look at this side here, what do we have? We have a ground, we have a hot leg, and we have a neutral. It's very important to understand. You only have 120 volts. So what this thing's doing to make everything work to go from 30 amp to 50 amp is now we're taking this ground right here. Let's do it this way so you can see it. So this ground here runs through the wire and connects to the ground right here. The neutral on this side, it goes over, oh, and connects to this one right here, the neutral up here. The 120 volt, the 120 volt, now connects to this one and this one. So if you take your test meter, when this is plugged into the box, and you check your voltages between this pin here and this pin here, you won't see anything because it's not different voltages, it's 120. So if you go between here and here, it's 120. You go between here and here, it's 120. But if you go between this pin here and this pin here, you don't see any voltage because it's 120 volts. If it had 120 volts here and 120 volts there on different legs from the service, then you would show 240. But if you go between here and here and here and here, you get 120 volts. Like I said, it gets confusing because you're talking about two different legs of power. You have L1 and L2 of power. L1, L2, okay? Inside of this plug, they are bonded together. L1 and L2 are connected together. So the power comes from L1 here and connects to this one and this one. So you only have 120 volts. You don't have 240. You only have 30 amp service. So it's easy to overload a 30 amp circuit. They also have adapters that go from the 30 amp down to a 15 amp circuit, which is your standard. Let me get one. This is a standard 120 volt, 15 amp plug. 15 amp, 15 amp. If it was 20 amp, if it was a 20 amp plug, then this one here, the positive or the hot side, the L1 side, would be sideways. I think I might even have one of those laying around, maybe. Nope, don't have one of those laying around, but I do have a twist lock. This is a 50 amp twist lock plug. This type here you will find on construction sites all the time. So what it has is it has a neutral, it has a neutral, a hot leg, and a hot leg. The neutral has the L shape, so you put it in, you twist it, and that locks it in place. This will do 220 volts or 115 or 120 volts, whichever way you wire it. It just depends on how you, but anyways, that's that one. This is another type of plug. This is a 50 amp plug. So what we have here is we have, let's see if we can get it. So we have your ground, you have 120 volts and 120 volts. So if you measure between here and there and there and there, you're going to get 120 volts either way. But if you measure between over here and over here, you get 240 volts, which makes it 240 volt plug at 50 amps. This is what you'll normally find on welders and things of that nature. Sometimes they'll look like a dryer plug. Dryer plugs is a perfect example of a 220 type of circuit, because you have two legs of 120. You have L1 and L2. Okay, you got to remember there's two different legs, and when you get into three-phase wiring, that's a whole different thing, because now you have L1, L2, L3. So that's a whole different ballgame. But you don't have to worry about that because we don't do three phases that often on trailers. We stick with the with a 120 single phase. Well, it seems that something happened there on that recording at the very end, because what I was going to say is for you to help you understand the difference between the L1 and L2. Let's take a look at your power lines coming into your house, because that's probably the easiest way to understand how it works, is starting at the source, which is where it comes from, at the power lines. Now this is a standard transformer that you'll find outside your house. You have, up at the top here, we have L1 and L2 on the 27,000 volts or primary side. The power runs down through some fuses, and the fuses are basically number 4 copper wire, and then they run into the transformer. The transformer is what they call a delta winded transformer, or delta winding. So out of the transformer we have leg 1 or L1 and leg 2 on the other side, and down the center we have a neutral tap. Those go down to your secondary wires, which run down to your house. The transformer you were just looking at is located on this pole right behind the tree there. So now we're going to follow the secondary lines. The secondary lines run up here to the pole, and then they run down here to my house on the service drop to my weatherhead. Most houses or most neighborhoods will have anywhere from 5 to 7 houses hooked up to one transformer. That transformer over there is 25 kilovolt, 25 kW. So Yeah, kilowatt. So we have 25 kW there, and it's hooked up to 5 to 7 houses at the maximum. So if you were to actually follow these wires, the secondary wires all the way down past the trailer and down to the next pole down there, you'll see that they just come to an end down there. They're connected together to insulators, but they don't actually connect anything together. They're just there to hold the poles together and to support each other. But if you go that way, you'll see they run up and they actually swing down. Over here, my neighbor has their service drops. They run in here, so there's two houses. There's a house here, and then the house is all behind me. You know, so you'll have anywhere from 5 to 7 houses on one service system. Now, I'm sure you're probably saying, why do I even care about how the power company gets the power to my house? When I flip the switch on, the dang thing works. Well, that's what I'm trying to tell you. All right, you have L1 and L2. These are separate systems. These two wires here, L1 and L2, go up to the transformer, and they're separate on the transformer. They're separated on the high voltage lines. They're separated all the way through the substation, and then to the not to the transformer, but to the substations, and all the way down to wherever you're getting your power from. And I'm talking the big power lines. They're all separated. So if you have the great big giant power lines that you hear crackling and humming with the big cable and all that stuff, you have, let's say there's 6 of those lines, all right? Those go to the generator. Well, the generator, it sends out L1 and L2. They basically send out L1 and L2, except on the transmission lines, we have L1 and L2. We just put it in multiple lines. We can have up to 4 sometimes. It just depends on how much load is on the other end. So you have the generator on one side and the load on the other end. Now, when you're getting into L1 and L2, since we're dealing with single phase here, it's pretty simple because you have just L1 and L2 and you have single phase. When you get into 3 phase, then you have to worry about the third leg and all that stuff. But that's all done on a transformer and everything else. But you know, we'll get into that. We can do that later at some point, but I doubt it. On your trailer, it's really simple because it's all single phase, so it makes it easy. We have L1 and L2. All you gotta do is think about that up there. So when next time you're outside, you look up at that telephone line, you're getting that telephone pole, you're gonna go, hey, that's L1 and L2 up on the very top on the primary. And you go, L1, L2 on the secondary plus a neutral. That's simple. So we have L1, L2. Basically, you're hooked directly to those lines through this one and this one. And of course, the ground goes to the earth, and the neutral goes to the neutral, which is connected to earth also in several different places. But that's pretty much how these things work. And like I said, when you get into this, if you're using a 50 amp cable or a 50 amp adapter down to 30 amp, you have to be careful on how many amps you pull on your trailer, because you can run an air conditioner, but you can't run a microwave at the same time. You can overload things and you'll burn up the plug. You can run your microwave and you can run the refrigerator and some radios and stuff and the coffee maker. You just don't want to pull more than 30 amps, because it's easy to pull more than 30 amps through your trailer by the way it's wired, because inside your trailer, the trailer thinks it's hooked up to 220 volts, you know. So it's thinking it has 2 hot legs it can pull 30 amps of power from, or 50 amps of power from, versus one leg, which is 30 amps of power. Because right now we're taking this one here and we're splitting it, wiring it into these 2 here. So these 2 are now the exact same, going through one little plug. And you don't want to overload this, because otherwise it turns black and it smokes and it burns up and you cause all sorts of problems and headaches later on. So that's how to be careful with this stuff. I mean, I could show you with a meter, which I might do right now. Okay, as I was saying, neutral, ground, L1, L2. So we take our test leads and we shove it up in the hole here, and we shove it up in here. There's I'm not getting it. There we go. There's 124 volts. That's that way. Now we take this and we move it over here to the other side. There's 120 volts, 122 volts there. If we go between here and here, we don't see anything because these are neutrals and grounds. But if we take and we go this direction here with it, now we have 246 volts. So you have L1, L2. Both of these are, like I said, if you think back to the transformer and also the power lines up there, you have L1 and L2. So this one here and this one here combined together makes 246 volts because it varies depending on the time of day and things of that nature for voltages. But if we go between this leg here, which is neutral, and then L2, we have 124 volts. Then we can move it over here. Do the same thing here. We have 122. Combine them this way, and we have 240. Now here we have the part that would be on your trailer to connect to your shore power. This is your shore power cable, and I currently have it plugged in. So the little LED that's on the top here is green. So what we're going to do is show you how this works. So we know that this is a ground. We're not sure what's in here, so let's find out. We can reach it. Nope, not get anything there. Okay, so there we have 124 volts between the ground and that L-shaped one up there. Now let's go to this one here, and we have 122 volts there. If we go between this one here, there's 120. Hard to get the thing in there. Oh, there it is. Come on. Touch. Touch. It's hard to reach into this neutral one. There's 124 volts there. Now if we go between this one and this one, we should get 220. Come on. Like I said, the probes aren't really long enough for these type of plugs. There we go. There's 240. So that there is your basic wiring on your trailer and your plugs from the transformers all the way down through the house, through the facility or whatever, into your trailer. Now let's go inside your trailer and go from 12 volts DC to 124 volts AC. This gets interesting because now we're using an inverter to create AC power from DC power. Amperages and voltage, those are completely different when you're talking about AC from DC to AC. We're going to draw a whole lot more DC amps to create the AC power that's needed. I'll show you. So now we've moved inside the trailer, and we're going to talk about this unit here. This is an inverter. This is a 3,000 watt inverter. This will produce 30 amps of power for me, or just about 30 amps of power. I have it connected to 3 lithium-ion batteries. These things will produce 100 amps of power each. So I have 300 amps of power total running through this. This is a 400 amp fuse because these can produce more than 100 amps each for what they call an inrush. The inrush is when you first turn something on, you get a lot of amperage draw. So anyways, I got 3 batteries down here. These are 300 amps total going into the 30 amp inverter. So what we're going to do is we're going to convert DC voltage to AC voltage. That's what the inverter does. It is currently on. And I'm going to show you just how many amps of power a shop vac draws, which is basically the same as a microwave. So here I have clamped my amp probe around the positive cable that goes down to the battery. So this way I can see just how many amps of DC power I'm going to be drawing to run an AC shop vac through the inverter. So let me get this zoomed in here real quick. All right. So right now we have less than 1 amp of power draw. That's just the microwave clock and the things that are in standby, like the television. We got 2 TVs and the microwave clock. So we're not even drawing 1 amp of power there out of the battery. So now let's go ahead and flip on the shop vac that I have. A shop vac is 120 volts and it's rated at 10 amps of power. Remember that, 10 amps of power. Currently we're drawing 0 amps of power. So let's turn on the shop vac and see just how many amps of power we get. So now I'm running the shop vac completely off of DC voltage, and I'm drawing 94.9 amps, 94. to 95 amps. Let's call that, yeah, let's just make it a nice even round. 95 amps of power. All right, there we go. Now the inverter's back to normal. So yeah, that's a huge amount of power. That's almost 100 amps of power coming out of the batteries. Let's go ahead and fire this thing up one more time so you can see that one more time. So here we have about 1 amp of power going out of the batteries into something. There's the shot vac. Pulling 90 amps of power. I'll turn the solar panels off, and now you can see it jumped up to 97 amps of power being drawn. Let me turn the solar panel back on. Solar power is back on, and now we're down to 93 amps. All right, now what did we learn by showing you this, or what did you learn, or what did I learn? Okay, here's our amp gauge. So what that shows you is now you kind of understand how the voltage and the power gets down to your house from the transformer through L1 and L2 all the way through the transformer and down into your house, where you still keep L1 and L2 separated, because the way those work is you have 60 cycle current. All right, 60 cycle means basically it's a wave pattern, and it goes between the negative line up, over, and back down 60 times. It does this every second. So the electrons flow from the generator to your house, through your device or your light bulb, and back to the generator 60 times a second. So the power is actually going back and forth 60 times a second. The power actually changes directions. You never see it because it happens so fast that your eyes can't see it, but you can see it on a camera. That is the shutter. You see the flickering lights of the camera. You know, the lights are flickering when you're watching a video or something. That is the 60 cycles of power that we're dealing with here in the US. 60. You go out to other countries and they have 50 hertz versus 60 hertz. When you're dealing with DC voltage, it's completely different, because then it flows from one side of the battery over to the other side, and it's a continuous loop that it keeps making. That's why we went with AC for powering everything versus DC, because AC is much more efficient than DC. So as you can see by watching the amp meter on the DC side of the batteries, just a 10 amp shop vac, right? 10 amps, that's it. That 10 amps isn't a lot. That's drawing 100 amps, almost 100 amps out of those 3 batteries. And I've only got 3 batteries. That's 300 amps total. 300 amps. Now if you take one battery has 100 amp hours in it. So if I was to take and just have one battery hooked up, I could turn on that particular shop vac running at 95 amps, and it'll run for 1 hour before the batteries are completely dead. 1 hour, that's it. Batteries are dead. These are lithium ion batteries, so they're completely different than a regular lead acid battery or a gel cell battery or an AGM battery, as we like to call them. So what you want to remember is when you're dealing with lead acid batteries and gel cell batteries, you don't want to draw them down to where they're dead. Because if you take a lead acid battery and you draw it down to where it's completely dead flat, you've just reduced the amount of amperage capacity that it can hold by 1/2. So if you have a 100 amp lead acid battery and you draw it down completely flat, you can charge it back up, which takes a long time to charge back up. It'll charge back up, but then when you turn on the power and you draw power from it, instead of it taking, let's say, an hour for it to draw down to 0, it'll take 30 minutes, because now you've cut the amount of amperage holding capacity in half. Excuse me. Because the acid moves into the lead plating, and it sulfates the plates in the battery. Thus we call it a sulfated battery or a dead battery. And you only want to draw a lead acid battery down to I think it's 11.5 or 11.2 volts, something like that, maybe 10.3 or 10.5 at the most on voltage. If you draw it down any further than that, you damage your batteries, period. End of story. The next time you use the battery, you're going to go, God, last time the batteries lasted forever. Now they don't last. Well, that's because you drew them down too far. On the other hand, these lithium-ion batteries, which are about $1,000 a pop, you can run those down until they go dead, and you can recharge them and go dead, recharge them, go dead, recharge them, go dead, and you do not hurt them. They're designed and they're manufactured to be cycled that way. The difference between manufacturing, like these are made by Battleborn. There's other manufacturers out there that are less expensive. Battleborn comes with a 10-year warranty, and what you're paying for not only is the warranty and how long it's supposed to last, but the actual little device that's inside there that monitors all the little cells and makes sure everything equalizes out properly and runs the way it's supposed to. That's basically what you're paying for, is the quality in that part, because there's only 3 or 4 manufacturers of lithium-ion batteries out there. But either way, you're still looking, when you start dealing with DC voltage going to AC voltage and doing an inverter, as you can see, a 10 amp shop vac really puts a big strain on a set of batteries. A microwave is the same thing. Microwaves are 20 amps of power draw. I mean, you turn a microwave on and it blasts it. It's the same thing. So you have to be careful when you're hooking up AC stuff to DC, and you're going to be using DC to power your AC system, because your amperages are completely different. So you have to watch your amperages, make sure that you know what you're doing there, and you don't kill your batteries. Otherwise, you're just throwing money out the window. I mean, you'll spend money on batteries like there's no tomorrow. So that's about AC, DC, and inversion in a nutshell, or in a horse trailer anyways. So once again, this is Crazy Marty. I hope you guys learned something, because I just ramble on about things. All right, I'll talk to you guys later. Bye-bye.